Welcome back. In the last video, we were introduced to matrix multiplication, which, although we haven't seen it yet, is one of the most common operations in neural networks. And we saw that you should always try to use Torch's implementation of certain operations, except if they're basic operations like plus, multiplication and whatnot, because chances are it's a lot faster version than if you were to do things by hand. And also, it's a lot less code. Like compared to this is pretty verbose code compared to just, hey, matrix multiply these two tensors. But there's something that we didn't allude to in the last video. There's a couple of rules that need to be satisfied when performing matrix multiplication. It worked for us because we have a rather simple tensor. But once you start to build larger tensors, you might run into one of the most common errors in deep learning. I'm going to write this down actually here. This is one to be very familiar with. One of the most common errors in deep learning, we've already alluded to this as well, is shape errors. So let's jump back to this in a minute. I just want to write up here. So there are two rules that performing, or two main rules that performing matrix multiplication needs to satisfy. Otherwise, we're going to get an error. So number one is the inner dimensions must match. Let's see what this means. So if we want to have two tensors of shape 3 by 2, and then we're going to use the @ symbol. Now, you might be asking why the @ symbol? Well, the @ symbol is like a operator symbol for matrix multiplication. So I just want to give you an example. If we go tensor @ stands for matrix multiplication. We get tensor 14, which is exactly the same as what we got there. Should you use @ or should you use matmul? I would personally recommend to use matmul. It's a little bit clearer. @ sometimes can get confusing because it's not as common as seeing something like matmul. So we'll get rid of that, but I'm just using it up here for brevity. And then we're going to go 3, 2. Now this won't work. We'll see why in a second. But if we go 2, 3, @ and then we have 3, 2, this will work. And then if we go the reverse, say 3's on the outside, 2's here, and then we have 2's on the inside and 3's on the outside, this will work. Now, why is this? Well, this is the rule number one. The inner dimensions must match. So the inner dimensions, what I mean by this is let's create torch rand. We'll create of size 3, 2. And then we'll get its shape. So we have, so if we created a tensor like this, 3, 2, and then if we created another tensor, well, let me just show you straight up. Torch.matmul, torch.rand, watch this, won't work. We'll get an error. There we go. So this is one of the most common errors that you're going to face in deep learning, is that matrix 1 and matrix 2 shapes cannot be multiplied because it doesn't satisfy rule number 1, the inner dimensions must match. And so what I mean by inner dimensions is this dimension multiplied by this dimension. So say we were trying to multiply 3, 2 by 3, 2. These are the inner dimensions. Now this will work because why? The inner dimensions match. 2, 3 by 3, 2. 2, 3 by 3, 2. Now notice how the inner dimensions, inner, match. Let's see what comes out here. Look at that. And now this is where rule 2 comes into play. 2, the resulting matrix has the shape of the outer dimensions. So we've just seen this one, 2, 3 @ 3, 2, which is @ remember, is matrix multiply. So we have a matrix of shape 2, 3, matrix multiply a matrix of 3, 2. The inner dimensions match, so it works. The resulting shape is what? 2, 2. just as we've seen here. We've got a shape of 2, 2. Now, what if we did the reverse? What if we did this one that also will work? 3 on the outside. What do you think is going to happen here? In fact, I encourage you to pause the video and give it a go. So this is going to result in a 3, 3 matrix. But don't take my word for it. Let's have a look. 3, put 2 on the inside, and we'll put 2 on the inside here, and then 3 on the outside. What does it give us? Oh, look at that. A 3, 3. 1, 2, 3. 1, 2, 3. Now, what if we were to change this? 2 and 2. This can be almost any number you want. Let's change them both to 10. What's going to happen? Will this work? What's the resulting shape going to be? So the inner dimensions match. What's rule number 2? The resulting matrix has the shape of the outer dimension. So what do you think is going to be the shape of this resulting matrix multiplication? Well, let's have a look. It's still 3, 3. Wow. Now what if we go 10, 10 on the outside, and 10 on the inside? What do we get? Well, we get, I'm not going to count all of those, but if we just go shape, we get 10 by 10. Because these are the two main rules of matrix multiplication. Is if you're running into an error that the matrix multiplication can't work, so let's say this was 10 and this was 7, watch what's going to happen. We can't multiply them because the inner dimensions do not match. We don't have 10 and 10, we have 10 and 7. But then when we change this so that they match, we get 10 and 10. Beautiful. So now let's create a little bit more of a specific example. We'll create 2 tensors. We'll come down. Actually, to prevent this video from being too long, I've got an error in the word error. That's funny. We'll go on with one of the most common errors in deep learning, shape errors. We've just seen it, but I'm going to get a little bit more specific with that shape error in the next video. Before we do that, have a look at matrix multiplication. There's a website, my other favorite website. I told you I've got 2. This is my other one. Matrixmultiplication.xyz. This is your challenge before the next video. Put in some random numbers here, whatever you want. 2, 10, 5, 6, 7, 8, whatever you want. Change these around a bit. 3, 4. Oh, that's a 5, not a 4. And then multiply and just watch what happens. That's all I'd like you to do. Just watch what happens, and we're going to replicate something like this in PyTorch code in the next video. I'll see you there.